This video is going to go over IPMix, our implementation of IP adapter within Shima. As with other videos, we're going to go through the nodes and tell you, what their functions are and whatnot. This is a pretty big workflow here, or template, so let's get right into it. In the upper left-hand corner, like with a lot of Shima stuff, we bring in an image, right? And currently we are bringing in gen image from a sampler that exists over here, specifically over here. You'll notice that we are using the same input here, or the same regex input name for both, right? We're piping gen underscore image to both of these. You could replace this by right-clicking and renaming the slot and say send this from a second sampler or FX pipe or something along those lines. You could also directly wire it up to an image loader if you needed to for whatever reason, right? So right now, though, what we're going to be doing is we're going to use the gen image for our image 1, and we're going to use a loaded image from a place that's dedicated to that within the workflow for image 2. Okay? The switches that control that are right here. There's select image 1 source from template workflow. Basically means that, hey, we're running this from or in conjunction with other portions of a system that will feed us this image. Alternately, we could use input image 1, which is just to the right of it. It'll just tell you, look over to the right, that's where it is. The same is true for input 2. So we can either feed it from a passer from the template workflow, or we can use image 2 input on the right, which is down here. On the left-hand side here, and in portions of the second column here, we have our control nets. So this works just like the control net modules previous, so we're not going to rehash that overly. You will select your control net image, you'll select the preprocessor that you want to use against it if you want to use one, and then that will get piped into image 1, 2, or 3 in the control net stack. As before, you can turn these control nets on and off as to whether you want to use control nets to define your final image. We will be using them on this workflow. Initially, we're just going to use anime line art with this particular image up here. As in other areas, we can control whether or not, or which of the 3 control net images we're going to use for our latent size. And then finally down here in this switch, we can choose whether we're going to use IP adapter image 1, meaning if you followed that wire back, this image here, or rather the image that comes out of this switch here, or alternately the control net image, right? So in this case, we are using the control net image as our latent size. Right below that is a LoRa stack, works just like all of them. And down here, as in a lot of other areas, you can choose whether you want to use the common seed fed from commons or a new seed here for your inputs. Moving on to the top of the stack here, we have a preview image that is simply just showing us what is coming out of the workflow that has been passed. Oftentimes you're going to pass one image in from the workflow. I guess what we might want to do, actually, let's do a little on-the-fly modification of this before, because all of this is pre-release, right? So even as I work through it, I find things like this where, oh, you know what, maybe we might need to preview that too. In the event that you are using two images that have been passed in, like maybe this is coming from a second sampler as an example, we might want to have a second preview image here. So let's go ahead and do that. We're going to make these a little less prominent as well. The purpose of these is really just to make sure that if you're passing images in, that you see what you're passing in before you push the Q prompt, and that you know that you've selected the right stuff. Okay. When we queue this later, since they're both gen image, we're just going to get identical images left and right. And I'll worry about getting this all tidied up in the final release, but it'll look pretty much just like this. Down below that, we have our load image 1 input. This is if we're not using these passers. We would select 2 for our source, and then we would choose an image that we wanted to pass in, whatever it happens to be. So I'm going to go back to 1 because I do want to use our passed in image here. Below that, we're getting image width and height information. And this yellow node here, it's yellow so that it's very prominent. IP adapter can be very memory intensive, and if you have a low memory video card, something that's a little bit older, you may have to reduce the size of these images by this factor. You are using this factor, I should say. Right now it's 1, which means it's going to use the actual size of these images. But if I had a need to, I could do 0.7 or something like that and reduce the overall memory requirements for the image. Of course, when you do that, you're also going to be reducing the detail and everything. So if you can run it at 1, that's great. But if you run into out-of-memory errors, try inputting a lower number here, some sub 1 number, and see if you can generate that way. Down here, load image 2, pretty easy. And these 2 images, combined with our control net and prompting information and everything else, are going to be used to create a merge into the model that we're generating from. And in this way, IP adapter is sort of like, it's often described as, this isn't me talking, this is how a lot of other people have described it, as a 1-image LoRa, right? So a LoRa is a model that you add into another model to give it direction on how to style your image. And usually those LoRa's, or not usually, always, those LoRa's have to be trained, and they're usually trained on anywhere from a dozen to hundreds of images, right? With IP adapter, we can use just a single image, and the system will use that to effectively patch the model and provide us with a model that has elements of the images that we are passing into it. Okay? Directly to the right of that, you're going to see these nodes. Now, really, there's only 2 that you need to care about. For the interest of space, I needed a lot of space anyway, so I didn't collapse these up like I often do into a single line or whatever. So you can sort of see the sausage being made down here, but effectively you don't have to worry about this very much. All you're doing is you're defining an X and Y position for this box, and that's because this box within IP adapter, it actually only uses a very specific size box for its attention area. And that box, I believe it's 224 pixels. My memory may not be serving me exactly correctly, but it's similar to that. And so what I've done here is, you have this left and right adjuster, right? So we can slide it to the left or to the right, and that will move this white box. You won't initially get this white box. It's unfortunately, I don't yet know how to make this interactive so that if I move it, the box moves at the same time. Not that good yet. I'm working on it. But what will happen is that you will generate and then you'll also know, the size of your image that's coming in, and by, guesstimation, you can say, oh, if it's at 110 and this is where the box is, and I want it to be, over here to get more of the ear, well, this box is 224 pixels, and so roughly, let's just say if we break it into fours, it's like 60 pixels each time. So to move it over where the ear is, I'd probably have to move it up to, 160 or 170 or something. The same can be done, obviously, here, right? So I'm going to reduce it a little here to 92, and that's going to move it up a little bit and get a little more of her eyebrow. But I also might say, I want to look more, at the clothing that she's wearing, so I could move it way down, right? And in this way, you affect the attention area, and you affect where in the image the IP adapter is going to use to generate its attention, right? Down here, we have the exact same thing, except we have it for the image 2. You'll notice that these boxes are differently sized, and that's because these images are differently sized, right? This top one is a smaller image, 512 by 816, and so the 224 box appears, larger within that space. One thing that can be done, and this is you'll create an error if you do this, but it'll be pretty obvious as to what you've done. If I move this a little too much, right, way outside, this will give me an error that says that it can't create an image outside the bounds of this image, right? So if you ever move these around too massively, rather than drag it, let's just type this back in. There we go. You might get that error. If you do, just pay attention, to how big your image is. If you start to move it partially off, this is what's interesting. If you move it to where like half of this box is off, it will still run. So I assume what it's doing, although it wouldn't be seen, is it's probably creating an image that is half nothing, black or white or something, and then on the other side, pixels from your image. So you have to go really far to make it just not work at all. That is our attention area. Okay, next up, our IP adapter types and whether we want to use 1, 2, or 3 of them at a time. Generally, I get good results with 1, but sometimes I'll try 2 just to experiment. You can enable them like so in any combination, and they will chain together using these automatic switches down here. So you don't have to worry about these, so don't. But that's what these do. That's what all these wires are doing. They're sorry, I should get this into the middle. These switches are controlling automatic selection of whether or not you have IP adapters engaged. All right, and directly below that, we have modified this slightly because there are sort of 2 different, well, there's probably more than 2, but there's 2 that I'm aware of, nodes for applying IP adapters, and both of them seem to give slightly different results. And so what I've done is I've given you both. So the first one over here is a little simpler to use, and you make your modifications down here. If it is on input 1, it's going to use this one, right? It's going to batch your images together and put them here, and then it's going to modify your image according to this IP adapter application. On the right-hand side, it has, if I was to select 2, it would move over and use these controls, or these nodes for applying your IP adapter. Here you have the ability to encode your IP adapter image with individualized weights for each image that you pass in, right? And currently we are only passing in two. I suppose we could extend it, to pass in. I don't know why load image didn't come up right away, but there we go. To pass in other images here, but we're not going to do that on the fly. So choose one, choose two. It just depends on your particular needs. Play around with it. Again, can't break it just by changing values. The most you can do is get an error. The same is true up here. Currently, we don't have Insight face integrated into our system. So you'll see that our IP adapter helper is showing not available. And so if I tried to select Insight face required options here, it will tell me, that it can't do it. So if you ever get errors after modifying these, then just check to see if you have your models installed and whether or not you have all of the required dependencies for those extra options, right? But oftentimes I'll just use, SD 1.5. It's pretty good, just as is. The other thing that I should mention is that there is a where is it? Oh, it's like staring me right in the face. You can choose this SD 1.5 plus here. If you do that and you are using this second setup here, make sure that you check this IP adapter plus to true, or you'll get an error, right? So that's effectively it for the application of your IP adapter. Finally, the easy part is down here. We have our conditioning area, right? So we've put LoRa's, etc. We've defined what our checkpoint is. We've defined what our LoRa type is. If we're adding in extra LoRa's within this loader and conditioning section, and we've put in our prompts, both positive and negative. And then the K sampler on the right works the way they all do, right? So of course we are filling in the noise seed here, so you don't have to mess around with this. But all these other settings work just as if you were generating normally. And finally we have our image 1 input preview so that we can see where we're coming from for our initial image that we're passing in from the sampler, most likely, and then the image output of the IP adapter. Down in the bottom right corner, your standard set of orange nodes that let you target groups, titles, inputs, the comparator output, and a mask input regex, and all of the associated nodes. And you also have two wired outs right here. So if you needed to or wanted to, you could use this to really quickly do a save image node or something like that, right? In fact, we'll just go ahead and do that just for grins, and we'll call it tutorial IP adapter. I'm just going to bring that off. All right, so let's go ahead and click Q prompt. And there it was. Pretty quick. So this is using the left-hand side IP adapter apply. Let's switch it over to number 2, and you can see just how significant the change is. So there we go. Now, there may be some settings here that we could put in. Like right now, let's just pretend that the weighting of these two images is both 1, and that, we've got weight of 1 over here. We are, oh wait, I don't want a noise of 1, sorry. We're going to say 0.35 on our noise. And we are going to say 1 and 1. And that duplicates this as much as we, reasonably can. And let's click Q prompt again and see if we get an image more similar to our original number 1 output. And the answer is no. We really don't. It's a very different result. And quite honestly, I'm not exactly sure why those two results are so drastically different. If you know, tell me in the comments. I am by no means a master of AI backend programming. So if there's something going on here that will help me increase my knowledge of it, that would be really great. If someone can explain why those two things are so drastically different. But because they both produce, results and understandable results, I went ahead and I just put both of them in so that you have each option. One of them in this particular setup, because we're working with, anime babes, looks significantly more anime than the other one. So, again, whatever your particular workflow need is, you will determine which one of these is best for you.